Hey guys, so now we're going to start question 3 of the identifying variables and their correlation worksheet. It says, base your answers to the following questions on the graph below and on your knowledge of Earth science. The graph shows the closest distance between Earth and Mars during each year from 2001 to 2035. Distances are measured in astronomical units or AU, and 1 AU equals the average distance from Earth to the Sun. So the question is asking, what is this graph about? So to figure that out, we can just read here, and I can say that this graph shows the closest distance between Earth and Mars during each year from 2001 to 2035. And in other words, every single year, the distance between Earth and Mars is different. So you can see that sometimes the distance between Earth and Mars is shorter some years, and some years the distance is a lot larger, meaning they're farther apart. And notice something interesting, the distance is actually measured in what we call astronomical units, or AU. AU is the average distance from Earth to the Sun, and this is very common. This is a very common unit used when we're measuring large distances between objects in space. It's so large we can't just use kilometers and meters like we do on Earth, or even miles. We have to use a unit that's basically equal to the distance from Earth to Sun and compare other distances in space that way. So, for instance, 2 AU would be a distance double the Earth to Sun, the distance between Earth and Sun. zero point 0.5 AU astronomical unit would be half the distance between Earth and Sun, and we can use that unit to describe other distances across space. So B asks, what is the independent variable? And C is asking, what is the dependent variable? Well, I'm seeing one of my variables is distance and the other is year. Year is not affected by the distance between Earth and Mars, but the distance between Earth and Mars is dependent on which year you're looking at it at to see the distance. So I would say the independent variable is year and the dependent variable is distance. D is asking, what is an astronomical unit? AU. It tells you right here. 1 AU equals the average distance from Earth to the Sun. So 1 AU equals the average distance from Earth to the Sun. And it's a very common unit used when we're talking about space distances. E is asking, in which year was the closest distance between Earth and Mars the smallest? Or this is kind of a typo. In which year is the closest distance between Earth and Mars? And what was the distance in AU, or astronomical unit, during that year? So we're seeing that sometimes Mars and Earth are closer, smaller distance, and they're sometimes farther apart, larger distance. So the closest distance looks like around here. This is the lowest distance. And if I look this way, it's somewhere between zero point 0.3 and zero point 0.4 AU. So what year is the smallest distance? I would say it's 2003. 2003, we had the smallest distance. Earth and Mars was very close to each other. But what about the actual distance during that year? So, if you're confused about what this number might be, go back to the scale of axis equation that we talked about. You can also go back to that video where I explain how to find the scale on any axis. So to figure out the scale of the distance, or the y-axis, I can do the pick any two values. In this case, the equation is the higher value that I'm picking minus the lower value I'm picking divided by the number of jumps between those values. So I'm going to pick 0 0.4 and 0 0.3, and I'm going to plug it into the equation. So higher value is 0 0.4 minus lower value is 0 0.3 divided by the number of jumps between those values. So to go from 0 0.3 to 0 0.4, it's 2 jumps, 1, 2. So I'm going to divide it by 2, and that gives me 0 0.5 AU, meaning each jump or interval changes by 0 0.5 AU. So if this is 0 0.3, this is 0 0.35, this is 0 0.4. So the distance is somewhere between 0 0.35 and 0 0.4. I'm going to say it's around 0 0.36. You can use another number somewhere in between. Next, identify the type of relationship between the closest distance between Earth and Mars and time. So I'm seeing it's the distance between Earth and Mars, or the closest distance every year. It's sometimes going down and then up and then down and then up and then down. It looks like a cyclic relationship to me, but I'm gonna double check because it could also be a fluctuating relationship. A cyclic relationship normally changes within a certain interval. It doesn't have to be the same exact interval every time, but it should be about the same. So I can just see how long it takes normally to go up and then how long or yeah, let's see how long it takes for it to go all the way up every time. So from here to here, it takes 1, 2, 3, 4, 5, 6, 7, 8 years for the distance to go from the lowest to highest point. And then let's see over here, it takes 1, 2, 1, 2, 3, 4, 5, 6, 7, another 8 years again for it to go up. And if I look at the downward and see and count it and see whether it matches on this side, and let me see. So from here, from the highest to the lowest point, it takes 1 years, 2, 3, 4, 5, 6, 7, 8, 8 years to go down back down to its lowest point or its closest distance. Let's see over here. It takes 1, 2, 3, 4, 5, 6, 7, 8 years again for it to go from highest to lowest point. So that's how I can tell it's a cyclic relationship. So I'm going to say there's a cyclic relationship between the closest distance between Earth and Mars and time. That's it.